Assalamualaikum and hi everyone. Today my friends and I will be presenting on methyl phenylacetate, a key compound that is responsible for the characteristic fruity aroma of honey. Honey is a sweet, viscous substance produced by the honeybees from the nectar of the flowers. While it is a primary component are simple sugars such as glucose and fructose. Its distinct fruity scents arise from the presence of the naturally occurring ester known as methyl phenylacetate. Chemically, methyl phenylacetate belongs to the homologous series of the esters, which is an organic compound that are commonly recognized for their pleasant aromas. It possesses the functional group carboalkoxide, which result from the reaction between a carboxylic acid and an alcohol. The IUPAC name of this compound is methyl phenylacetate, and it is also widely known by its common name, which is methyl phenylacetate. This compound can occur naturally in various plants or be synthesized in the laboratory for use in fragrance and flavorings. So, let's go through a chemical properties first. To begin with, the molecular formula for methyl phenylacetate is C9H10O2, which indicate it consists of 9 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. The molecular weight is 150.18 grams per mole. Next, we have the partition coefficient that commonly expressed as a log P, which in this case range approximately from 1.91 to 2.09 at 20.9 to 25 degrees Celsius. The partition coefficient is a ratio that describes how a compound distributes itself between two immiscible solvents, typically water and an organic solvent. If the value of P more than 1, it means a compound is more soluble in organic solvent, while if the value of P less than 1, it means a compound is more soluble in water. In terms of stability and shelf life, the compound is noted to be stable under recommended storage conditions. This implies that when stored properly, it will maintain its chemical integrity. As for decomposition, when the substance is exposed to high temperature, it will emit a crisp smoke and irritating fumes. This slide shows the physical properties of the compound. To begin with, the appearance of the compound is described as a colorless to pale yellow liquid, accompanied by a strong sweet honey-like aroma. Its boiling point, it ranges from 215 to 217 degrees Celsius, while its melting point lies between 49 to 15 degrees Celsius. The density of the compound is measured at 1.062 gram over milliliter. Next, the refractive index ranges from 1.503 to 1.509. So, what is a refractive index? A refractive index is a measure of how much light bends or refracted when it enters a substance from another medium. The vapor pressure is between 16.931 to 362 pascals at temperature ranging from 20 to 50 degrees Celsius. Vapor pressure is defined as the pressure exerted by a vapor in thermodynamic equilibrium with its liquid phase at a given temperature. A higher vapor pressure indicates greater volatility of the compound. The vapor density of the compound is 5.18. Vapor density is the ratio of the mass of a given volume of the vapor to the mass of an equal volume of hydrogen at the same temperature and pressure, whether it will rise or settle. Lastly, the compound is soluble in organic solvents such as oil but insoluble in water, glycerin, and propylene glycol at 250 degrees Celsius.
Next, we are going to move on to the chemical reactions. Methyl phenylacetate can be found naturally in plants and honey, but we can also make them synthetically in the lab through esterification from carboxylic acid and acyl chloride. Esterification from carboxylic acid is when a carboxylic acid reacts with an alcohol to produce an ester with its byproduct, which is water. In this case, phenylacetic acid reacts with a methanol to produce methyl phenylacetate. For esterification from acyl chloride, an acyl chloride reacts with methanol to produce methyl phenylacetate. Methyl phenylacetate can go through reactions such as base hydrolysis and ammonolysis. For base hydrolysis, methyl phenylacetate reacts with base to produce a salt and alcohol. This process is also called saponification because the salt has the molecule of a soap. Next, for ammonolysis, methyl phenylacetate reacts with ammonia to produce a primary amide and methanol. Honey is very beneficial and useful for humans, especially for humans' health. There are key bioactive compounds such as flavonoids, phenolic acids, organic acids, and hydrogen peroxides in honey. Flavonoids such as phenocyanidins and crysine are potent antioxidants. Antioxidants are very good for anti-inflammatory effects and anti-aging effects. Phenolic acids such as gallic and caffeic acids are also antioxidants. They also possess antimicrobial properties. Next, organic acid. Gluconic and acetic acid provide antimicrobial actions. They also regulate honey's pH, which is typically 3.5 to 4.5. Lastly, hydrogen peroxide. Hydrogen peroxide is produced by glucose oxidase. It provides antibacterial effects. This is crucial for honey's healing properties. Studies have shown that honey has many benefits for human health. For example, it is wound healing because its antibacterial properties reduce healing time by 20 to 30%. Also, it is a good cough suppressant because it is comparable to dextromethorphan. It effectively soothes cough naturally, and some cough syrups have honey as their main ingredient. Next, antioxidant effects. Honey protects against oxidative stress, and this is to reduce the risk of chronic illnesses. Lastly, Manuka honey. Manuka honey has unique methyl glycosol content which provides strong antibacterial activity. This means that it is very good for fighting antibiotic-resistant bacteria.
Now, let's take a closer look at the benefits of honey to living organisms. Firstly is the pollinator help. Honey provides an essential energy source for bees. It is rich in natural sugar primarily from fructose and glucose, which fuel the bees' physical activities, including foraging and maintaining hive functions. Secondly is a larval nourishment. Honey serves as a crucial food source for developing bee larvae. Its availability supports proper growth and development, which is fundamental to sustaining healthy and productive bee colonies. Lastly is antimicrobial protection. Honey possesses natural antimicrobial properties that help protect bees from various pathogens. This functions as a natural defense system, contributing to the overall immunity and hygiene of the hive.
Okay, so honey demonstrates several significant environmental applications. The first one is the soil amendment. As a soil amendment, it enhances soil structure and promotes beneficial microbial activity that is fostering healthier plant growth. And the second one, it is also functioning as a biopesticide. Honey exhibits potent antifungal effects that it is effectively inhibiting fungal development on crops without relying on synthetic chemicals. And lastly, honey is fully biodegradable, meaning it decomposes naturally and leaves no lasting environmental pollutants. This makes it a sustainable and eco-friendly alternative in agriculture. Okay, so now let's dive into how honey works its magic in the industrial world. First, in the food industry, honey is a superstar natural sweetener, but it's more than just sugar. It's also used as a preservative because of its low water content and antimicrobial properties. That means it helps keep food fresh longer. Plus, it enhances flavor, adding that rich floral note you can get from plant sugar. Second, in cosmetics, honey is gold. It's a powerful moisturizer and humectant, which means it draws moisture into the skin and keep it there. That's why you find it in face masks, lotions, and even lip balms. It's also packed with antioxidants, giving it some solid anti-aging power, think natural glow, not expensive serums. And lastly, in the pharmaceutical industry, honey's healing properties shine. It is used in wound care, especially for burns and cuts, because it's antibacterial and promotes faster healing. You also find it in cough syrups and antibacterial ointments, where it soothes and protects. So really, honey isn't just sweet. It's smart, sustainable, and kind of a secret weapon across multiple industries. Okay, for the conclusions, to sum up, the organic compounds found in honey, like glucose, fructose, and flavonoids, are what give honey its unique taste, texture, and health benefits. These compounds contain important functional groups such as hydroxyl and carbonyl, which affect how they behave chemically and physically. Honey isn't just sweet, it has antioxidant and antibacterial properties, making it useful in medicine, food, and skincare. By understanding the chemistry behind these natural compounds, we can better appreciate how honey works and why it's been valued for centuries. It's a perfect example of how simple natural substances are, full of complex and useful chemistry.